Hi everyone. Today I wanted to share an unusual aspect of the way that GHC reduces type families, and this is a sort of a dark corner that gets people stuck. So actually, there's a proposal right now about fixing this dark corner, but it will affect user-facing design. So it might be nice to know a little bit about what's going on. So here's our example module here, pick type, and what I want to do is I want to write a type family, pick type, where I choose, I have a number here, and depending on the number, it's going to pick a different type. So pick type of 1 might be int, pick type of 2 might be bool, pick type of 3 is maybe. So let's see about that. Illegal type 3. So we always have to add a bunch of these extensions. So I can already see I'm going to need type families, and I know we'll need polykinds and we'll need data kinds. Whoops. Let's see, does that do enough? So now we get a type error. Type errors are going to be important today. So here, expecting one more argument to maybe. Really expect that a type it maybe has kind star or star. So here, the result kind changes. Sometimes it's int, sometimes it's maybe. So that's problematic. So, let's just say this returns something of kind k. But now we get this other error. Int has kind star, but we're expecting kind k. So the problem here is that these different equations have different instantiations for k, and that's a form of what's called polymorphic recursion. When we have an implicit parameter here of a function, essentially, that is then instantiated at different types in different places, that's very hard to do for inference. So instead of allowing this, what we will need is what's called a standalone kind signature. So what we write here is I'm going to write type pick type, and what's its type? Well, it's going to be nat to k to type. Sorry, that's not right. It's going to be nat to k. Nat to k. It takes a number and it returns some type of kind k, but we don't know what k. So now I can actually leave that off there. And then now, it doesn't like that because I have not enabled standalone kind signatures. I have a very bad feeling. Yes, I have a very bad feeling. We're on the wrong GHC. That's a shame. I'll be right back. Okay, I'm back. Here we have now GHC 8.10. We were on 8.8 before. So that problem is avoided. Let's see, not in scope nat. Well, that's easy to fix. Okay, here we are. So far, this looks pretty good. But we can actually already run into some trouble. So I can evaluate type families in GHCI by using the kind exclamation mark command. And so if I say kind exclamation mark of pick type 1, it doesn't evaluate to int. So that's a little peculiar. But maybe that's okay. So we'll come back to that. But that suggests that maybe there's something wrong here. What I want to do now is I will write a function print type, which for all n, it's going to give me a string, and print type is going to be the show of type rep at pick type n. So the idea is that pick type is going to pick out a type, let's say int or bool or maybe, and then I get the type representation for that type, and I'm going to show it. So this is a string. I would really actually prefer this to use visible dependent quantification and to require this n argument. But GHC does not support that yet. That's proposal 281, which is a bit out of the way here, so we're not going to go to it. But it's the fact that this is implicit is a bit annoying. And so, indeed, we need to add new extensions now. So we're going to need type applications. It says rank n types, but it really wants me to turn on scope. Type variables. Okay. Now type rep is not in scope. So that comes from type.reflection. And here, expected kind nat, but n has kind k1. That's because we don't know what it should be. So we've got to tell it that it's in fact a nat. No instance for typable. Well, that makes sense, right? So the typable constraint is saying that we know what this type is at runtime. Normally types are erased in Haskell, so it would be very hard to implement a function like print type which has different behavior for different types unless we pass something in that somehow represents the type. That's exactly what typable is. So I'm going to write a typable constraint here. So typable pick type n. So now we have that typable constraint, and now we try to compile flexible contexts. Okay, so now we get, something about allow ambiguous types. Well, that kind of makes sense, right? This is an ambiguous type. I'm mentioning n here in a context, but not in the type itself. So let's turn on allow ambiguous types. Could not deduce typable pick type n from typable pick type n. Oh, we're starting to get in trouble here. We're getting into the bad corners of GHC. So the problem is that we have too many kinds, and we're not seeing them in our output. So a better GHC would say something about maybe we should turn on print explicit kinds, but this GHC is not smart enough to do that. So we're going to turn that on and then try to recompile. And now we get something slightly more informative. Could not deduce this typable k0 pick type k0 from the context typable k pick type k. So now we see a difference. So this is an improvement. But what's odd here is that my pick type, it looks like it just should have one argument n. But here, when I'm writing out the explicit kinds, I see that it actually has two arguments. It has an argument k as well as n. The idea here is that when I said that pick type has kind nat arrow k, well, really, this is for all k, nat arrow k. And so it turns out that this choice of k matters. And so what I need to do now is I need to say that this is going to be the same k in both places. That's a bit hard to do without introducing another parameter. So we're going to introduce this new k here and say that this is going to be the same in both places. Great. So now that problem is solved. So does that mean we're home free? So if I say int equals, int is a string, and I want int to be print type at 1. I'm choosing type 1. Let's try to compile that. Oh, now we get this no instance thing again. And the problem really here is that even though I have pick type 1, I can't reduce that yet. And that's because each of these equations have an invisible pattern match in them. For this to be well typed, right? Now let's look at pick type. Pick type, its first argument is the kind of its result. So that means that for this equation to be well typed, the invisible argument needs to in fact be type. And so let's comment out this problem down here for a sec. Not in scope. Let's fix that. And so now that works. But of course, if I put in the wrong thing here, we would get a type error. Right? This is no good, right? Because I've said that the result of pick type is going to be this, is going to have this kind here, and int does not have kind type arrow type. That's no good. So this needs to be just plain old type. But what this means is that each of my pick type equations has this invisible argument that is in fact controlling its reduction. And so because of this invisible argument, now down here, when I try to compute pick type 1, well, I can't actually reduce pick type 1 because I don't know, I need to pattern match on this first argument. So what I need to do is I need to pass in this at type, and things have gotten sort of swizzled around in print type, so it ends up to be the second argument here. So if I say at type here, now suddenly we're okay again, and indeed this works. So the key bit here is that my initial definition of pick type, I didn't write out these invisible pattern matches, yet they controlled reduction of my type family. And this is why earlier, when I tried to write kind of pick type of 1, I didn't get a reduction because I didn't know what k was. So if I say kind of pick type at type 1, now it reduces to int. Or I could say kind of pick type 1, and then here, type inference can also figure out what it should be, and that will give me int as well. So this is a bit strange and confusing. We've gotten a number of bug reports over the year of, clearly pick type 1 should be int. Why aren't you reducing GHC? That's very silly. And so there is a proposal. This is proposal number, where is it? Where's the number? Is the number really not on the screen anywhere? I guess not. This is some number. I will link to it. I think if I cleverly go back. Oh, it's number 386. Proposal 386. It has here change number 2. Let me make this bigger for everyone. Change number 2. Introduce the following rule. In a type family instance declaration, the instantiation of the type family instance is fully determined by the left-hand side without looking at the right-hand side. So that change number 2 would fix this problem, because it means that I'm not going to infer these invisible things on the left-hand side just by doing type inference on the right. And so I think that should clean up this small area of GHC. Hope this has been interesting. Thanks for watching. Bye.